Hello, chemistry people. What I've got for us today is a video that is a demonstration that I did in class a couple of days back. It is a really great demonstration of how catalysts work, and it's a really great demonstration of showing that activated complex. So what I'm going to do, I am going to pause for this now, and then I'll speed up the video, and I'm cutting out the audio because I did record it in a class where I had students, and for my students' privacy, it's not going to have any talking over it. But I am going to pause throughout the demonstration and then put up a diagram with a reaction profile so we can see what's happening at a more fundamental level. So if you'll excuse me a second and enjoy the show. Hydrogen peroxide and Rochelle salt react and form a gas, and they do that by transferring electrons between them. Now, something we spoke about in periodicity is that the transition metals are particularly good at having those variable number of electrons that they give up, and that makes them very good as acting as catalysts in this type of reaction. So initially, my Rochelle salt and my peroxide don't seem to be reacting. They are in fact reacting very slowly. But once I add my cobalt, and it is that pinkish cobalt color, you'll see that my reaction becomes a whole lot faster. So let's check that out. So when at the beginning of this demo, I have just my peroxide and my Rochelle salt sitting on a hot plate. Now that is an exothermic reaction. So if we look at the reaction profile, what we see, we have our reactants here. And then we know that for an exothermic reaction, my delta H is negative. So sorry, that is less than 0. And that is my products down here. Linking these two things, I have my activation energy and then my delta H. So this distance here from my reactants to the top of my hill is my activation energy. This point at the top of my hill where my reactants have the most energy that they're going to get, this thing here is called the activated complex. So let's go back and I will add the cobalt and we'll see what happens. So when we add a catalyst, what we're doing, and this is the definition that the IB want us to use, so make sure we're using the right definition. Catalysts decrease the activation energy by providing an alternate reaction pathway. So catalysts do not change the delta H. This is still is less than 0. That's an exothermic reaction. This delta H that I've drawn in this second diagram is exactly the same magnitude as the one I've drawn on my first diagram. What adding that cobalt does though, it increases, it gives a different step. It provides an alternate reaction pathway. So first, I have my peroxide reacting with my cobalt, and then I have my cobalt reacting with my Rochelle salt, my tartrate ion. So I have this first activation energy and then this second activation energy. Those two together is a lower activation energy than my uncatalyzed reaction. This is what a catalyst does. Instead of taking one massive jump from up to my activation energy, it breaks it into smaller steps, each of which are comparatively easy to complete. Now we get into more detail with stepwise reactions in HL. But the thing to note is that this guy here, this activated complex, this is where cobalt 2, which is pink, becomes cobalt 3, which is green. So let's go back and watch that demonstration, because you will see the point at which that pink cobalt 2 becomes this really lovely sort of emerald green cobalt 3. Now, when that cobalt 3 is formed and it's that lovely green, I actually grabbed some of that solution and put it in an ice bath so we could see really clearly this colour change here from the cobalt 2 to the cobalt 3. Okay, so let's finish off our video. So you can see that at the end of the reaction, my cobalt has returned to its original state, that pale pinkish colour. But you can see that I've actually frozen, literally, because I'm using very cold water, some of that cobalt in that activated complex state in the cobalt 3 form. So that brings us to the end of our demonstration. Thank you so much. Have a fantastic rest of your day, and I shall see you next time. Bye.